Welcome to the Copperfield Electric Podcast. I had a bit of a humbling moment this past weekend. I consider myself reasonably handy. I can hang a picture frame. I can assemble flat-pack furniture without, crying. But I was standing in the aisle of a hardware store, staring at a wall of white plastic squares.
Ah, yes. The wall of outlets.
Just rows and rows of them. And honestly, they all looked exactly the same to me. But then I squinted at the little price tags and the tiny embossed letters on the faceplates, and I saw these numbers, 15 amp, 20 amp, and I had this moment of total paralysis.
The hardware store paralysis. It happens to the best of us.
It really did. I realized I have absolutely no idea what the difference is or why I should care, other than maybe one costs 50 cents more than the other. I mean, a hole in the wall is a hole in the wall, right? I just want to plug in my new table saw and make some sawdust. But something told me I shouldn't just guess.
And that instinct probably saved you a melted circuit, or at the very least, a very frustrating afternoon of tripping breakers.
It's funny you mentioned the table saw, because
Yeah.
that is the classic scenario where this distinction stops being, academic and starts being a real-world problem.
See, that's exactly why we're doing this.
Ah,
Today, we are digging into what you call the invisible infrastructure inside our walls. We're unpacking a technical guide on amperage selection, and we're looking at the expertise provided by Copperfield Electric, a local expert service right here in Southern California.
right.
Our mission is pretty simple but vital. To answer that question, do I need a 15 amp or 20 amp outlet?
Mm-hmm.
And to understand why getting it wrong involves more than just a nuisance.
Exactly. It's about decoding the language of the wall socket. We often treat electricity like magic. You plug it in, it works, you forget about it. But electricity demands respect. It follows physical laws. And when you try to force more power through a system than it's designed for, well, the physics bites back. Physics bites back is a phrase that should worry any homeowner. So let's start with the basics. The tale of two outlets. In one corner, we have the 15 amp. In the other, the 20 amp. What is the standard here? Because when I look around my living room or my bedroom, I assume those are all the same type.
And you'd likely be right. The 15 amp outlet is the everyday workhorse. It is the Honda Civic of the electrical, world reliable, ubiquitous, and designed for the daily commute of electrons.
Okay.
If you walk into a standard bedroom or living room in a typical residential home, especially one built in the last 40 or 50 years, this is what you're going to find. It's the default.
So this is the one handling my lamp, my TV, charging my phone, that kind of thing.
Precisely. The source material highlights that 15 amp outlets are ideal for lamps, televisions, computers, and small kitchen appliances. Think about the devices you use that don't generate massive heat or don't have giant motors that need a huge kick to get started. Your laptop charger draws very little power. Your LED TV, surprisingly efficient. These are all considered lighter loads. The 15 amp outlet and the circuit it lives on handles these comfortably without breaking a sweat.
Okay, so that's the standard. It covers probably 80% of what we do in a house. Yeah. So when do we need to call in the heavy artillery? When does the 20 amp outlet enter the chat?
The 20 amp is the powerhouse. You generally find these where the work gets harder. The source identifies these as necessary for high-draw appliances. You'll see them in the garage, the laundry room, and increasingly in the kitchen.
Give me some specific examples. What counts as high draw in a normal house?
Think about things that have two main jobs: heating things up rapidly or spinning something very heavy. Air conditioners are a classic example. That compressor needs a lot of juice.
Okay.
Large microwaves. Power tools like your table saw. Commercial equipment. If you're in a workshop running a compressor or in a kitchen with a high-end espresso machine or a heavy-duty blender, you are likely crossing into 20 amp territory.
It's interesting you mentioned the kitchen. I feel like the kitchen has changed a lot in the last 20 years. It used to just be a fridge and a toaster. Now it's air fryers, pressure cookers.
That's a great observation. Our energy density in the kitchen has skyrocketed. An air fryer is basically a high-powered heating element with a fan. It draws a lot of current.
Right.
If you plug an air fryer and a high-end blender into the same 15 amp circuit, you're going to have a problem. That's why modern code often requires 20 amp circuits in kitchens.
Okay, so I want to talk about the physical difference for a second. Because when I was at the store, I noticed the 20 amp outlet looked slightly different. It had a little sideways slot.
Right. That's the T-slot. If you look at a standard plug, it has two vertical prongs. A 20 amp outlet has a T-shaped neutral slot. It looks like a little winking eye on the left side.
A winking eye, I like that.
That is there to accept a specific type of plug, the NEMA 520.
The NEMA 520. Sounds like a sci-fi robot.
It's just the technical name for a plug that has one prong turned sideways. And that design is intentional. Manufacturers put that sideways prong on high-draw devices, like big AC units, so that you literally cannot plug them into a standard 15-amp outlet. It's a physical safety mechanism.
So it stops you from making a mistake.
It tries to.
Okay, so here is the million-dollar question. And I feel like this is where the DIY mindset gets people in trouble. Let's say I buy a fancy new window AC unit. I get it home, I'm sweating, it's hot, I go to plug it in, and it has that sideways prong. It won't fit in my wall.
Right.
Can I just run to the hardware store, buy a 20-amp faceplate, which fits in the same hole in the wall, swap them out, and force the plug in?
No, absolutely not. Please, if you take one thing away from this deep dive, let it be. No, do not do that.
You sounded very serious there. Why not? If the plug fits, why doesn't it work? I mean, the electricity's there, right?
The electricity is there, but the capacity to carry it safely is not. By swapping the faceplate, you're only changing the terminal, not the infrastructure behind it. This is where we get into the why. An outlet isn't an island, it's the end point of a system.
A system.
That system includes the circuit breaker in your panel and, crucially, the wiring inside the wall.
So the wires themselves are different. I always assumed a wire is a wire. Copper is copper.
Copper is copper, but the amount of copper matters immensely. This is the critical wiring factor. A 20-amp circuit uses thicker wiring than a 15-amp circuit. Specifically, we're talking about wire gauge.
Wire gauge, okay.
A 20-amp circuit typically uses 12-gauge wire, which is thicker. A 15-amp circuit uses 14-gauge wire, which is thinner.
And just for clarity, in wire gauge, the smaller the number, the thicker the wire.
Correct. It's counterintuitive, like shotgun shells. 12 is bigger than 14. That thicker 12-gauge wire can carry more electrons, more current, with less resistance.
Okay, I think I see where this is going. If I put a 20-amp outlet on that thin 14-gauge wire,
you're writing a recipe for disaster. Think of the wire like a garden hose. If you try to force a fire hose volume of water through a skinny garden hose, the pressure builds up to a bursting point.
yeah.
In electricity, that pressure manifests as heat. If you put a 20-amp outlet on a 15-amp wire, you're telling the appliance, sure, go ahead and pull 20 amps. The appliance tries to pull that power. The thin wire resists it, and that resistance creates heat.
And since this wire is inside my wall,
It's touching wooden studs, it's touching paper drywall, it's wrapped in plastic insulation. When that wire heats up, the insulation can melt. Once the insulation melts, you get earthing sparks jumping between wires. And that is how house fires start.
wow.
You are essentially turning the wiring inside your walls into a heating element, like the coil in your toaster, but without the safety cage.
That is a terrifying image. But wait, what about the breaker? Isn't the breaker supposed to be the bouncer? If I try to pull too much power, shouldn't it just trip and save me?
Ideally, yes. If you haven't changed the breaker, it should trip at 15 amps. But here is the insidious danger we see in the field. A homeowner swaps the outlet to 20 amps. Then they plug in the AC. The breaker trips. They get annoyed.
I can see that happen.
They think, oh, the breaker's just weak. So what do? They go to the hardware store and buy a 20-amp breaker and swap that out, too.
No. So now the breaker allows 20 amps. The outlet allows 20 amps.
But the wire in the middle is still rated for 15. You've removed the safety limit. The breaker won't trip because it thinks 20 amps is fine. But the wire is cooking. You have effectively bypassed the safety system of your home.
Yeah.
The source material is very clear. A 20-amp outlet must be connected to a 20-amp breaker and utilize the proper gauge wiring. You cannot cheat the physics.
That is a sobering reality check. It's not just swapping parts like Lego blocks, it's a holistic system. Okay, so let's pivot to the practical side. I want to be safe. I'm a listener standing in Home Depot or I'm looking at a new appliance. How do I actually make the right choice without burning my house down? Is there a checklist?
There is, and the source outlines a very logical decision matrix. It's a 3-step process. Step 1 starts at the panel.
The breaker box. The gray metal box in the garage or the closet that everyone is afraid to touch.
That's the one. You need to check the circuit breaker. Go to the panel and find the switch that controls the room or the specific outlet you're working on. Read the number stamped on the handle of the switch. Does it say 15 or 20?
And that's it. That's the law.
That is your hard limit, correct.
Yeah.
You cannot negotiate with the breaker. Step 2 is evaluating the device. Look at the appliance you want to use. Check the plug. Look for that sideways prong or check the label on the back. It will list the amperage rating.
And step 3.
Match them up. If it's standard electronics, lamps, computers, you stick with 15. If it's high-powered equipment, you need 20. But here is the catch. If your device needs 20 and your wall only gives 15, do not use an adapter. do not change the outlet, you need to upgrade the circuit.
And that leads nicely into the benefits of doing it right. Why would someone want to go through the trouble of installing a dedicated 20-amp circuit? It sounds expensive and messy to run new wire.
It's an investment in safety and performance. First, obviously, safety. But secondly, usability. We've all been there. You turn on the microwave and the vacuum at the same time and pop, everything goes dark.
Yes, every time.
A proper 20-amp circuit prevents that. It handles the startup surge of motors much better, and of course, it's good for future-proofing.
How so?
Well, our energy needs are always changing. We have more devices, more powerful tools. Having 20-amp circuits provides flexibility for future upgrades. It ensures you aren't constantly operating at the red line of your electrical capacity.
Okay, let's unpack this. We're talking about breaker panels, dragging new, thicker wires through walls, and calculating loads. This has firmly moved out of the Saturday afternoon DIY category for me. This sounds like a job for a pro.
And it should be. Electricity is one of those fields where the cost of a mistake is incredibly high. It's not like painting a wall the wrong color where you can just paint over it. If you get electricity wrong, the consequences can be immediate and dangerous.
Which brings us to the experts behind the information we're discussing today. Copperfield Electric.
Right. They are the source of this deep dive's expertise, and looking at their profile, they seem to be exactly the kind of people you want handling this invisible infrastructure.
So let's talk about who they are. They're a local outfit, right?
Yes, based in Tustin, California. They serve Orange County and the broader Southern California area. They specifically list Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Laguna Beach, and Mission Viejo.
I love that they list the specific cities. It makes it feel much more like a neighborhood service than some giant faceless corporation that dispatches a guy from 3 counties away.
Well, and they are a family-owned business, which usually brings a different level of care. You're dealing with neighbors. But they back that up with credentials. The source explicitly mentions they are highly trained, background checked, bonded, and insured. They even list their license number 1094740.
I always look for the license number. It's like a badge of legitimacy. If you're hiding that, I'm suspicious. But if it's front and center, I know you're playing by the rules. What kind of work are they actually doing? Is it just swapping outlets?
No, it's comprehensive, and this connects right back to our 15 versus 20 amp discussion. They do panel upgrades. So if you do need that 20 amp circuit for your new wood shop or your high-end kitchen remodel, they're the ones who can upgrade the panel to handle it.
And what else? I saw something about EVs.
Yes, EV charger installation for homes and businesses, that's a huge topic right now. An EV charger is basically the ultimate high-draw appliance. If you buy a Tesla or a Rivian, you can't just plug it into a standard bedroom outlet and expect it to charge in a reasonable time.
Right, it would take days.
Exactly. You need a dedicated high-amperage circuit. You definitely need professional eyes on that. They also handle lighting and dimmer repairs and electrical installation for new construction, including ADUs, those accessory dwelling units that are popping up everywhere.
I noticed they also mentioned LED lighting being energy efficient. It seems like they cover the whole spectrum from saving money on lights to rewiring a new house.
But there was one thing in their profile that really stood out to me: their troubleshooting philosophy.
Yes, honest electricians who will only diagnose a problem if it truly exists.
That is golden.
Uh,
How many times have you worried that a technician is going to find a problem just to charge you for fixing it? It's a real anxiety for homeowners.
It's a common fear. But Copperfield explicitly states their value proposition is honesty. They also note that troubleshooting your home can save you money in the long run. It's that preventative mindset again.
Catching it really.
Catching a loose wire or an overloaded circuit before it burns out the panel or the house is always cheaper than the alternative. And they are available when things go wrong, right? Because power outages rarely happen at 2 p.m. on a Tuesday. It's always right before Thanksgiving dinner or in the middle of the heat wave.
Exactly. They offer 204/7 emergency services. They have a great line. You've got enough worries, let us take care of the lights.
That's a good slogan.
Yeah.
It's reassuring. If you're in Tustin or anywhere in Orange County and you smell burning plastic at 3 a.m., you can call 626-622-9694. That availability is crucial.
It is. And it ties back to the local codes and best practices. We touched on this, but it's worth reiterating. The experts at Copperfield emphasize that local codes, specifically in Orange County, require proper circuit sizing.
Yeah, people sometimes roll their eyes at codes. They think it's just bureaucracy or red tape. Oh, the city just wants to make my life hard.
But if you talk to a pro, like the folks at Copperfield, they'll tell you. Code is written in safety. Those regulations exist because somewhere, at some point, someone did it the wrong way and it caused a disaster. Adhering to code isn't just about passing an inspection, it's about keeping the house standing.
So when they say you cannot put a 20-amp outlet on a 15-amp circuit, that's not a suggestion. That's a rule for survival.
Precisely, and that's why the troubleshooting service is so valuable. If you are unsure if you're buying an older home in Santa Ana that was built in the 1950s, or you're renovating a spot in Newport Beach, having a licensed electrician come in and just look at what you have can save you a fortune.
It's like a health checkup for your house. We go to the doctor, we take our cars in for service, but we ignore the electrical system until it fails.
It is. The source mentions that if you haven't had your home checked regularly, or if you're concerned about a malfunction, they can come diagnose it. They've learned the ins and outs of the industry to get the job done on time and on budget, and they offer a 100% satisfaction guarantee.
That's bold. It shows confidence. So bringing this all back to our listener who is maybe standing in that hardware store aisle like I was, staring at the little white boxes, what is the big takeaway here?
The big takeaway is, don't guess. Amps aren't just numbers. They represent the flow of energy that can be dangerous if mishandled. 15 is for your TV, 20 is for your AC. And the most important part is the invisible part. The wiring inside the wall must match the faceplate on the outside.
Right. You can't just put a Ferrari engine in a go-kart and expect it not to fall apart. You need the chassis to support it. In this case, the chassis is that thick 20-amp rated wire.
That's a great analogy. And if you don't know what chassis your house has, if you don't know what's behind the drywall, don't unscrew that plate yourself.
That's the bottom line. If you are unsure, or if you need that panel upgrade to handle the new reality of modern appliances and EVs, call the pros. Copperfield Electric is there for a reason. They're licensed, they're local to Orange County, and they're family-owned.
And remember that number, 626-622-9694? Or look them up in Tustin. Whether it's 2 p.m. or 2 a.m., they're ready to handle it.
So tonight, when you go home, I want you to do something. I want you to find that gray metal box in your house, the breaker panel. Just open the door and look at the switches.
It's a fascinating exercise. We focus so much on the devices we buy. We obsess over the specs of the TV, the efficiency of the fridge, the power of the microwave. But we rarely think about the veins of the house that keep them alive.
It's true. We treat the house like a magic box that just gives us power whenever we ask for it.
But the panel is the brain. It's sitting there silently telling you exactly what your home is capable of handling. It has hard limits. And knowing those limits, knowing whether you're a 15-amp house or a 20-amp house, is the difference between a home that works for you and a home that works against you. So take a look. Do you actually know what your limits are?
Something to think about. Thanks for listening to the Copperfield Electric Podcast. Stay safe, and we'll catch you on the next Deep Dive.